we're going to talk about geometric sequences, and we'll review arithmetic sequences as well. So you can see the parallel. What is a sequence? A sequence is nothing more than a list of numbers. Okay. Describe the difference between the two sequences. Well, just take a look and stop the video and see if you can tell the difference. In the first sequence, there's a common difference of 2. Keep adding 2 to get to the next term. Okay. In the next sequence, you keep multiplying by 2 to get to the next term. So in both cases, you are using a constant to get to the next term, from one term to the next, but you're using a different operation. So if the operation is addition, we call the sequence arithmetic. If the operation is multiplication, we call it geometric. Okay, so arithmetic sequences we learned about a few months ago, and we couldn't learn about geometric back then because we needed to fill in a few gaps. So we're talking about geometric now when we're trying to connect the arithmetic and the geometric. Okay. So let's look back at these two sequences. So the first one, if you try to graph it, so the numbers in the sequence are your y values, your outputs, and your inputs would be the position of each number. So your n would be 1, 2, 3, 4, meaning the first term is 3, the second term is 5, the third term is 7, the fourth term is 9. So n would be your domain. So when n is 1, the number is 3 in the sequence. When n is 2, so the first number is 3, second is 5, and so on. Okay, so that's how you would plot a sequence. Sequence is a function. It's a domain of natural numbers. Okay. So look at them, and what do you notice about the graphs? Stop the video and try to see if you can figure it out. I mean, it's pretty clear from the first one anyway, what kind of shape the graph has and what kind of shape the second one has. So if you notice, the arithmetic sequence, when you graph it, it creates a linear graph. Okay? I could connect these with a line. There are no points in between these points. Okay? But these points do lie on a line. Okay? And by contrast, in the second one, in the geometric sequence, that creates an exponential graph. So those are two things you have to remember. Arithmetic sequence creates linear graph. Geometric sequence creates exponential graph. Okay. So this is review on the left, the arithmetic, that's review. And the formula for that was this right here. And what I'd like you to do is really to look at the geometric one and try to figure out a formula. It's very similar. If you remember the way we came up with this formula, in the arithmetic sequence, what you're doing is you keep adding the same number over and over again, called the common difference, d, right? So you start with a sub 1, you add d to it, it becomes this. Now you add d to this, the second term, and it becomes that, because now you have 2 d's. Then you add d again, it becomes this, and so on. So you are starting with, so each term is based on what you started with, which is a sub 1, and you're adding the common difference n minus 1 times, right? In other words, if you're looking for the third term, let's say, which is this one, how many times did you add d? Twice. Once from here to here and once from here to here. So you get to the third term, you add the d twice. To get to the fourth term, this is the fourth term, you added d 3 times. So to get to the nth term, you're going to add d n minus 1 times, right? If you notice, 2 is less than, 3 is, let's see how to explain this easier. This 2 over here is 1 less than 3. This 3 is 1 less than 4, right? So this 4 stands for the fourth term, a sub 4, right? This is a sub 5. So the subscript, if you notice, is 1 more than the number multiplied by d. So that's how we got that. We started with a sub 1, and you add d n minus 1 times. For the geometric, you also have a constant, but we can't call it d because then it'll be confused with the arithmetic difference. So we're calling it r for ratio. And so if you start with a sub 1 and you multiply a number by it, let's say r, you get a sub 1 times r. And if you multiply r again, you get a sub 1 times r squared. You multiply r again, you get a sub 1 times r cubed, and so on. So the formula here is similar to the arithmetic one, a sub n equals a sub 1, but now you're multiplying r n minus 1 times, and r times r times r times r n minus 1 times becomes r to the n minus 1. So there's your exponential equation. Okay, so this is the one you need to memorize, the nth term. So we'll have a couple of examples. So this is review. We've done this before. It's probably in your first review booklet that you made. Maybe. But here it is. If you don't have it, take your notes. And the new one for today is this. The geometric sequence is one in which the terms are generated by multiplying a constant r repeatedly. This is represented by an exponential function. And n is the position of the term in the sequence. A sub n is the nth term, a sub 1 is the first term, and r is the common ratio. So we'll do a couple of examples here. The local football team won the championship several years ago, and since then, ticket prices have been increasing by $10 a year. The year they won the championship, tickets were $60. A, write the ticket prices for the first 5 years. What type of sequence is this? Well, so if they started with 60 and they increased by $10 a year, then it would be 60, 70, 80, 90, 100. And because you're adding, there is a constant common difference of 10. This is an arithmetic sequence. Okay. And now we're going to look for the equation. So find an expression for the ticket price in the nth year and use it to find the price of the ticket after 20 years. First, we're going to find the general formula. So we're starting with the actual formula for the arithmetic sequence. Our a sub 1 is 60, right? And so we're going to substitute that. Our d here is 10. That's what we multiply by. And that's what we get. And if we simplify it, distribute the 10, get 10n minus 10 and combine like terms. 60 minus 10 would be 50. So our formula is 50 plus 10n. Okay. N represents the number of years here. So after 20 years, if I replace n with 20, I get $250. Okay, so this was an example of an arithmetic situation, arithmetic sequence that yields a linear equation. Okay. Here's an example of a radioactive substance that decreases in amount by 1/3 each year. If the starting amount of the substance is 3,645 grams, write the amounts for the first 5 years. What type of sequence is this? So it's decreases in amount by 1/3 each year. Okay. So the first year is 3,645. Well, 1/3 of that is, so let's start with the calculator. So 1/3 of 3,645. Let's see what that is. That's 1215. So that's how much the next year we have. Now we take 1/3 of that. So if we take 1/3 of the answer, we get 405. Now the answer being 1215. You could have written 1215, but that's a pretty cool way to have the calculator do it for you. Just press control -sign. See, it says ants at the top there. So 405. So we keep doing this, and these are the amounts. So because we're multiplying by a constant, this is a geometric sequence. There's a common ratio, 1/3. Okay, part B, write a formula for the amount of substance after n years and use it to find the amount of this substance after 10 years to the nearest hundredth. So we're using the geometric sequence formula, which is that. A sub 1 is the original number. the rate is 1/3, the rate or the ratio. To the n minus 1. So it looks as if I made a boo-boo here. Let's put it in, no worries. That should be n minus 1. And so this should be n minus 1, so that'll be slightly different answer. Let's put it in. So this would be 3645 times 1/3 to the 9th, because you're multiplying 1/3 9 times. So here's the example here. You multiply, in order to get to the 5th year, you multiplied 1/3 4 times. So to get to the 10th year, you multiply 1/3 9 times. I should have caught that. Excuse me. 3645 times 1/3 to the 9th. 3645 times 1/3 to the 9th. That would be 5/27. I think, let me show you. You can number convert to decimal and enter. So that's how you would convert it to decimal, or you could leave it as 5/27. Okay, but it said to round to the nearest hundred, so this would be 0.19 then. Okay, 0.19 of this. Can you imagine? 3,645 grams, and you end up with 0.19 grams. So yeah, exponential growth. If something increases exponentially, that means it grows really fast. And if it decays exponentially, like here, that means it goes down really, really fast too. That's it. I hope you enjoy the lesson. Have a great day. Bye-bye. Bye-bye.